Have you ever wondered what caused the birth of our universe? What was that explosive moment that sparked the creation of everything we see today? This question brings us to the concept of the Big Bang, the widely accepted theory for the origin of the universe. Imagine an infinitesimally small dot packed with unimaginable heat and energy. This is what we call a singularity. From this singularity, the universe exploded and expanded, cooling over billions of years, forming galaxies, stars, planets, and everything else we observe today. The Big Bang Theory provides an elegant explanation for the existence of the cosmic microwave background radiation, the large-scale structure of the cosmos, and the abundance of light elements like hydrogen and helium. But is the Big Bang Theory the only explanation for the origins of our universe? You might be surprised to learn that there are several other theories. Imagine a tiny seed exploding into a universe in less than a second. That's the idea behind the inflation theory. This theory, a modification of the original Big Bang theory, suggests that our universe underwent a period of rapid expansion almost immediately after the Big Bang. It's a concept that's as mind-boggling as it is fascinating. To paint a picture, imagine the universe in its infancy, smaller than an atom. Now, in a fraction of a second, it balloons to an astronomical size. We're talking about an expansion faster than the speed of light. This theory was proposed by physicist Alan Guth in the late 20th century as a way to explain some of the puzzles of the Big Bang theory. So, what's the significance of this rapid inflation? Well, it helps to solve several issues with the original Big Bang theory. For instance, it explains why the universe appears to be flat and why it's so consistent in temperature, despite being so vast. It also provides a plausible explanation for the existence of galaxies and clusters of galaxies we observe in the cosmos. However, as with any theory, the inflation theory isn't without its critics and controversies. Some scientists question the idea of a universe expanding faster than light. Others wonder about what might have triggered this rapid inflation. This theory solves several problems with the original Big Bang theory, but it also raises new questions of its own. The exploration of these questions continues to push the boundaries of our understanding of the universe, making the inflation theory a cornerstone in cosmological research. What if the universe started from a point of infinite density and temperature? This is what the singularity theory proposes. The singularity theory, a mind-boggling concept, suggests that our universe originated from a singularity, an infinitely small, infinitely hot, infinitely dense point. Now that might seem a bit hard to wrap your head around, but let's dive a bit deeper. In the realm of physics, a singularity is a point where some property or quantity becomes infinite or undefined. In the context of the Big Bang, it's the state from which the universe is thought to have sprung. It's like the universe was compressed into a tiny, almost non-existent dot before it started to expand in the Big Bang, around 14 billion years ago. But here's the catch. While the singularity theory provides a mathematical explanation for the origin of the universe, it's also fraught with paradoxes and mysteries. One of the biggest questions is, what happened before the singularity? If time and space began with the Big Bang and the singularity, then the concept of before might not even make sense. And there's more. The laws of physics as we know them break down when applied to a singularity. So we're left with a theory that, while fascinating and mathematically sound, doesn't really fit into our current understanding of the universe. The singularity theory provides a mathematical explanation for the Big Bang, but it's also fraught with paradoxes and mysteries. Could our universe be just one in a cycle of expansions and contractions? The Big Bounce theory thinks so. Welcome to the fascinating realm of the Big Bounce theory. This model suggests that, instead of being a one-time event, the creation of our universe might be part of an infinite cycle. Picture the universe as a cosmic accordion, constantly expanding and contracting. Each cycle concludes not with a Big Bang, but with a big bounce, a point of maximum contraction that leads to a new expansion phase. This theory takes a swing at the notion of singularity, the idea that the universe started from an infinitely dense point. Instead, it proposes that the universe never shrinks to a singularity. Instead, once it contracts to a certain minimal size, it bounces back. But how does this bouncing happen? Physics suggests that as the universe contracts and densities increase, repulsive gravity effects could come into play, causing the universe to bounce back. The Big Bounce theory is rooted in quantum mechanics, which allows for these kinds of fluctuations. However, the Big Bounce theory is not without its challenges. Critics argue that it requires conditions before the Big Bang, a concept that doesn't sit well with everyone. Furthermore, it's difficult to test this theory, given the enormous timescales and exotic physics involved. This theory provides an intriguing alternative to the one-time event of the Big Bang, but it's not without its challenges. What if our universe was born out of the collision of two three-dimensional worlds? Welcome to the Ekpyrotic Scenario. The Ekpyrotic Scenario, a term derived from the Greek word ekpyrosis, meaning conflagration or in fire, is a model that proposes an intriguing alternative to the traditional Big Bang theory. According to this scenario, our universe didn't start from a single point or a singularity. Instead, it was born out of the collision of two three-dimensional worlds, or branes, existing in a higher dimensional space. This collision, rather than being a violent explosion, was more like a slow burn, heating up and generating matter and energy over time. The branes, before colliding, were mostly empty, devoid of matter and energy. But the collision, the ekpyrosis, ignited a process that resulted in the creation of the universe as we know it. This model neatly sidesteps the singularity problem that plagues the Big Bang theory. There's no need for a point of infinite density or temperature. Instead, the universe begins from a relatively benign state and slowly evolves over time. But like all theories, it's not without its challenges. The mathematics of higher dimensional spaces is notoriously complex, and the concept of branes is still largely theoretical. This theory offers a radical departure from the Big Bang theory, but it's still a work in progress. From cosmic eggs to quantum fluctuations, there's no shortage of alternative theories about the origins of our universe. Let's delve into a few other theories that might not be as popular as the Big Bang, but are nonetheless intriguing. First up is the oscillating universe theory. This concept suggests that our universe has been expanding and contracting in a cyclic pattern for eternity. It's a bit like the universe taking a cosmic breath, expanding outwards and then compressing back inwards over and over again. Next, we have the quantum fluctuation model. This theory proposes that our universe sprang into existence from a tiny, random fluctuation in the vacuum of space. It's like the universe just popped into existence from nothingness due to a quantum hiccup, so to speak. Lastly, let's consider the cosmic egg theory. This ancient idea, found in various cultures, imagines the universe as hatching from a primordial, cosmic egg. Contemporary versions of this theory suggest that a high-density state, or egg, existed before the universe began expanding. These alternative theories each have their unique perspectives and interpretations of the universe's origin. Although they may not be as widely accepted as the Big Bang theory, they provide valuable insights and provoke thought. After all, the quest for understanding our universe's beginnings is a journey, and every theory is a stepping stone along the way. These theories may not be as well known as the Big Bang theory, but they offer fascinating alternatives to consider. So where do we go from here? What's the future of our understanding about the origins of the universe? The realm of cosmology is an ever-evolving field. As we continue to delve deeper into the mysteries of the cosmos, our theories about the Big Bang and the origins of the universe may shift, evolve, and even be completely redefined. Our understanding of the universe is like a jigsaw puzzle, and every piece we add changes the picture. Right now, we're making strides in research, gathering more and more of these puzzle pieces. We're venturing into the farthest reaches of the cosmos, using cutting-edge technology to peer back in time and observe the universe in its infancy. Technological advancements are the key to this process. With new observational tools, we can pick up signals from the distant universe that were previously undetectable. These signals, like cosmic microwave background radiation and gravitational waves, provide vital clues about the universe's beginnings. Additionally, the rise of quantum computing and artificial intelligence could revolutionize the way we analyze and interpret this data. These tools could help us make sense of the vast amounts of information we're gathering, potentially leading to new insights about the universe's origins. As we continue to push the boundaries of what's possible, we can expect to see an evolution in our understanding of the Big Bang and the early universe. As our technology advances and our understanding deepens, who knows what new theories we might uncover. The universe is a vast, complex mystery, and its origins are one of the greatest puzzles we're trying to solve. Today, we've journeyed through the cosmos, exploring a multitude of theories about the birth of our universe, each one as fascinating and diverse as the stars themselves. We began with the inflation theory, a concept that paints a picture of the universe rapidly expanding from a state of extremely high density. Then we delved into the singularity theory, which proposes that the universe originated from a point of infinite density and temperature. From there, we ventured into alternative models, such as the Big Bounce theory, suggesting a cyclical universe, forever oscillating between expansion and contraction. And the Ekpyrotic Scenario, a model that introduces the possibility of our universe being born out of the collision of two three-dimensional worlds in a space with an extra dimension. We also acknowledged a collection of other theories, each offering unique perspectives and contributing to the rich tapestry of cosmic understanding. And finally, we looked ahead to the future of cosmology, a future filled with relentless exploration and unending discovery. But remember, as vast and varied as these theories are, they are all part of our ongoing quest to understand the origins of our universe. None of them are the final answer, but rather pieces of a puzzle that is yet to be fully assembled. So next time you gaze up at the night sky, remember, the story of our universe's beginnings is still being written. Before we wrap up, let's make this journey of discovery a collective one. Did you learn something new today? If so, show your support by giving this video a like. Perhaps you have your own thoughts or theories on the origins of our universe? We'd love to hear from you, so don't forget to share your thoughts in the comments section below. And remember, learning is a continuous process, and to ensure you don't miss out on any future journeys through the cosmos, make sure to hit that subscribe button and press the bell icon. This way, you'll be notified every time we publish a new video. Lastly, if you think this video might spark curiosity in someone you know, don't hesitate to share it with your friends and family. The universe is a vast and fascinating place, and the more we explore it together, the more we can understand. So let's continue this journey of understanding the cosmos together. Until next time, keep looking up and keep asking questions.